Hello students, and in this lecture we will study that is fluid friction and frictional force. Now in the previous lecture we have studied a lot of things like what is friction and why friction is important, what is the effect of friction, advantage, disadvantage of friction. Also, we have studied a lot of things that is types of friction. Static friction, sliding friction, rolling friction, all these things we have studied. Here we will study fluid friction. The name specifies fluid. That means we will study the frictional force that is faced by the object which is in the fluid, right? And next topic that we will cover here, that is the frictional force. That is the frictional force. Okay, so let's start the journey. Now, one swimmer is here. So fluid friction. Now, fluid friction, that means air, water, other liquids that collectively are called here fluids. As we have seen that whenever one aeroplane is flying, at that time a very big sound is there because it just crosses the air friction. So, and water also, whenever you can see the ships, they are moving on the water surface. At that time, the water surface also, it exerts some force, that is the fluid friction. So, collectively, we are calling here air, water, other liquids that are fluids. That are fluids. Okay, what? Air, water, and other liquids. So they also exert a frictional force on the object that travels through them. For ship, it is applicable. For any person that swims, that it is applicable. So this force is called the fluid frictional force. The amount of frictional force by the fluid, the amount of frictional force by the fluid on an object depends upon different points. So here you can see that the swimmer, whenever it just swimming, at the time of swimming, he has to apply a lot of energy to move forward because there is some frictional force acting on this. He wants to move in this direction. So the frictional force, always we know that it will be acted in the opposite direction, right? So it will resist him, but he wants to move forward. So at that time he has to apply more force, more energy he has to apply. Now, what are the things that is responsible? The speed of the object with respect to the fluid, the nature of the fluid, its viscosity or tendency to resist the flow, the shape of the object, right? The shape of the object, that is also important. A big shape or very small shape, that also differs. Now, so the fluid frictional force that depends on these 3 points. First, what is the speed of the object with respect to the fluid? Next, the nature of the fluid, that is the viscosity or its tendency to resist the flow, and shape of the object. Now, fluid friction comprises internal and external friction. Fine. So, internal friction, when it occurs between the molecules of liquid as they are also in motion. Suppose you want to swim not in the swimming pool. That you have a flow of water, not in the swimming pool. In the swimming pool, the water, that is only steady water. So that I am not talking about that thing. Suppose some stream is there and you want to swim there. At that time, some internal friction will be applicable. The viscosity of the liquid, that depends upon the internal friction. And external friction in fluids, is the force that exerted by the fluid on the object that flows through it. That flows through it. So this is the external friction. Now, if the object travels in the fluid, then it loses its energy. Like a swimmer, whenever swims, he loses its energy. So, in order to overcome the fluid friction, why loss? Because in this picture you have seen that some frictional force acting here, and the swimmer, he is trying to move. He is trying to move in this direction. So he has to apply the more force than the frictional force. That's why as an object travels in a fluid, it loses its energy to overcome the frictional force. That is fluid friction. Ships, boats, but those boats, big ships, small ships, so these are, and also submarine, this allows them to resist the fluid friction. Birds, aeroplane, they have a specific shape that allows them to fly in the air, but in the air it has to face the air friction. So here that means the shapes board, this will resist the fluid friction. Birds, aeroplanes, they will resist the air friction. Fishes, and you know that fishes, they have a particular shape and they are trying to move forward with their tail and fins, swim continuously in the water. So they are losing the energy due to the friction, fluid friction. The vehicles are designed in a way that they can resist the fluid friction because air is present everywhere, right? Here you can see the objects, birds, aeroplanes, fishes, they are using particular shapes to avoid the air friction. They cannot avoid the friction, but the friction will be less due to the shape, because we have studied already this force, fluid friction, this force that depends on the shape of the object also. What is the frictional force? Now, friction is the force that resists the motion when the surface of one object comes in contact with the surface of another, right? Fine, we know this thing, because if there is no contact with in between these two surfaces, there will be no friction. If this object and this one, this object and this path, they comes into contact, at that time there is a friction. So here the frictional force that opposes to the applied force, right? When we try to push this block, at that time the friction will be acting in this direction. So now if we want to calculate the force of friction, here the maximum amount of friction force that a surface can apply upon an object, that is the mu into F naught. Now here F frict, that is the frictional force, mu coefficient of friction, F norm, that is the normal force. Okay, got it? So, and F frictional force, that equals to mu into F naught. Now, this numerical, we are trying to solve this one. Here, Nancy, let me change the color of the pointer. Okay. Here given Nancy of mass 40 kg. Nancy of mass 40 kg. So here mass is 40 kg is slipping on the frost. If the coefficient of friction acting is 0.45, find the frictional force and acting between her and the frost layer. So here given mass of Nancy that equals to 40 kg. Let it be M. Then coefficient of friction that is mu, that is here 0.45. Find the frictional force acting between her and frost layer. So here first the normal, just a minute, why it is coming I do not know. The normal force F norm that equals to M into G, where M is 40, G is 9.8. Okay, meter per second square. G is the 9.8 meter per second square, where G is the gravitational acceleration due to gravity. Okay, so the frictional force that is F frictional, that is mu into F norm. That means this will be 0.45 into 40 into 9.8. Okay, so you have just understood this thing, how we are doing this thing. So here 0.45 into 40 into 9.8, so that is 176.4 Newton. Okay, 176.4 Newton. So here that is the solution. So here you can write the answer. Write the answer. That is frictional force. Frictional force acting between Nancy and frost layer is 176.4 Newton. Okay, this is the answer. Now, a child is pulling a box of mass 10 kg. What is the standard force acting, and also calculate the frictional force if the coefficient of frictional force is mu equals to 0.3. Let's solve this one. Given, what are the given data? Child is pulling a box of mass 10 kg. So mass of box, let it be M, that is 10 kg. Oh, sorry. That is 10 kg, right? And here let normal force, that is F norm, that we know that m into g, where g is the gravitational acceleration due to gravity. So here we can write 10 into 9.8. So this is 98 Newton, and this is the standard force acting. Now if frictional force that we are, sorry, just a minute. F friction that equals to F norm into mu. So this will be 98 into 0.3. So that will come 29.4 Newton. So here we can write the answer. Standard force acting on the box is 98 Newton, and frictional force is 29.4 Newton. This is the answer. Now another question, that is 4 cubical box says made up of same material are placed on the ground and are pushed on a constant force d1, d2, d3, d4, where d3 greater than d2, greater than d4, greater than d1. So the sides a1, a2, a3 and a4 for respective boxes are related to which one in this option? So this one is the correct option. Next, Ted learns about force of friction. He tries out different ways of reducing as well as increasing the friction on the surface of his driveway. So in order to increase the friction on the surface of the driveway, Ted should what he should cover it with small pebbles, cover it with wax, pour water on it, pour oil on it. So to increase friction, cover it with small pebbles. This is the right answer. Now these are the possible questions that may come. What is the force of friction? In lecture 1 I have described. What is the cause of friction? That also I have described regarding with respect to molecules. What is the force responsible for wearing out of bicycle tires? Is the friction same for all objects? Why are wheels of vehicles made circular? What is the direction of force of friction acting on a moving object? And why do pieces of luggage fitted with rollers? You can see all the luggages, they have the rollers. Why does a matchstick catch the fire when rubbed on the rough surface of box? What is the name of special shape given to objects moving in fluids? Give one example where ball bearings are used. Does friction depend on nature of the object? So these are the possible questions. If you learn very well lecture 1 and lecture 2, you can answer all these questions. Thank you.